Law of cosines hopefully is another review topic for you, but I'm going to go through how you derive it in case you've never seen that part before. And this should get you set up for everything you'll need to do on the homework. So to derive it, I'm going to start with the same kind of idea as I did for law of sines, where I drop a altitude or plumb bob from the angle up here. Angle B is not labeled, but it's really not going to be important to the rest of the process here. Now, some things I'm going to do a little bit different. Since I'm doing cosine, I'm just kind of assuming that putting cosine in here would be a good idea since it's law of cosines. So if I'm going to deal with cosine for A and C, that's going to involve these adjacent pieces here. Because I've split this up into two right triangles now. So we can do some right triangle trig with a sine, cosine, tangent if we need to. So cosine's the way to go. Well, I know the whole thing's B, so I need to kind of make up something. And I'm going to make up X. I'm going to say from, or just this segment here, let's call it X. And if the whole thing was B, then that's going to make the rest of this B minus X. So I'm not truly making up anything. I'm just splitting it up into an unknown part, and then the whole side B minus that unknown part. So it's true what I'm making up here, but I am creating some new variables. One more thing I'm going to add, I'm going to call this H for height, because I've got a feeling that knowing this opposite side may be important as well. At this point, I would start coming up with any cosine ratio you can. There's kind of four main things I'm going to list out. So let's start with cosine of A. All right, well, that's going to be this side over C, so B minus X over C. If I set up a cosine involving angle C, it's going to be X over A. And then I would think about Pythagorean theorem. So this one's probably a little simpler. You know that A squared, the hypotenuse, is equal to X squared plus H squared. And if we use this bigger triangle over here, C squared is going to be equal to B minus X quantity squared. Make sure you put all that in parentheses. If you don't, that can mess some things up, because it's this whole side, B minus X squared, and then plus H squared. Okay, so I've got four equations here that this is going to be enough to get me to the law of cosines. All right, so at this stage, it may not be clear exactly which way to go. So I'm going to do something that I kind of typically do when I'm trying to verify or prove something. I'm going to take the piece that has the most stuff to it and work with that. These they're all kind of involving, but I would say this one kind of has the most variables, most pieces to it. So I'm going to pick this equation, and I'm going to expand on it, and then I'm going to substitute things in as I can from the other things I know to be true. So let's expand it. B minus X squared, all right, well that's B minus X times itself. You FOIL that out, or if you do the little binomial shortcuts, that's B squared minus 2BX plus X squared. That's what you're going to FOIL this part. And then plus H squared at the end. All right, well, I know that H squared, I can solve for it over here. So I'm going to rearrange this piece. If I wanted H squared by itself, then I would just have to subtract off the X squared on both sides. So H squared is really A squared minus X squared. All right, so rather than do a lot of rewriting here, I'm just going to scratch that and replace it with A squared minus X squared. Just substitution. Now let's simplify and see where we are. So C squared is B squared minus 2BX. This plus X squared, this minus X squared, they cancel out. And then plus A squared at the end. The only thing left that I really don't want is this X. And I really would kind of like to see a cosine get involved here somewhere, since it is called law of cosines. So the thing that's probably the simplest to solve for that involves X would be this one. If you solve that for X, you're going to get A times cosine C. So we'll rearrange it and use that. At the same time, I'm going to rearrange some of the, just using commutative property, just kind of reorder this. So side c squared, I'm going to put these in alphabetical order, so a squared plus b squared minus 2b, and I'm going to substitute this in for x. A cosine c. That's pretty much done now. That's your law, and I'll explain kind of how to recognize things. You know, the way you'll generally see it, a squared plus b squared, you'll see the a and the b reversed, but it really doesn't matter. And then cosine c at the end. So what you're really looking for, and once you do a few of these, it's not too bad to memorize. Most people get it within a few problems. It looks kind of crazy, but it's really just Pythagorean theorem with this little adjustment at the end. So where it's kind of different than Pythagorean theorem, whichever side of the triangle is by itself, regardless of whether it's hypotenuse or whatever it is, on the other side of the equation, you put the other two sides squared plus each other. So it's sort of like Pythagorean theorem in that regard. And it's always minus 2 times the other two sides multiplied together. And here's really the key thing to remember. Whatever side you have over here by itself, the angle across from it is the angle you're taking the cosine of. And then really you can, it doesn't matter what you call A, B, and C. That's really what it comes down to. Whatever side you have by itself here, the angle you take the cosine of over there. And then the other sides just kind of go in these spots. Before I do any kind of solving, let's go ahead and put the formula up here. I'm going to try to do it the way the book probably gives it to you, which is starting with a squared on this side. It really doesn't matter what you call these sides and angles. The main thing, and what you're going to see in just a second, is whatever angle you have here, you're taking the cosine of that angle, you've got to use the opposite side as the piece that's by itself. So in this case, if I've only got one angle, I really want to be looking at focusing on taking the cosine of that at some point. So the opposite of the 25-degree angle is this side x. So that's the piece that's going to be by itself. And then you really don't have to get too hung up on the b's and c's. It's just those are the other two sides. So 12 squared plus 9 squared minus 2 times 12 times 9 times the cosine of that 25-degree angle. And now we just start working this out. So x squared is 144 plus 81 minus about 195.76. And as always, I'm going to use all the decimals in the calculator as I go forward. So when I put everything in the calculator, I get x squared is about 29.24. And if I take a square root, 5.41. Not too worried about the plus or the minus because this is a distance, it's a length of a side of a triangle. It really does not make much sense for that to be negative. So side length really needs to be positive here. And x is going to be 5.41. So that's how you would use law of cosines to solve an unknown side. And on the homework problems, you're going to continue this on and have to find the other two angles. So just use whatever you can. Law of sines is usually a little bit easier. And use some geometry if you need to as well.